With the database hooked up, we can now store and retrieve data and display it in our API. I'm going to create a new controller to do this. So with the API project open in Visual Studio Code in the Explorer panel, I'll right-click on the Controllers folder, and then I'll select New C# class. And I'll name it Conference Controller. Visual Studio Code will create and stub out the Conference Controller class, and it will place the class in the server.controllers namespace based on the file structure of the project. Now recall that in an earlier video, we saw how all Web API controllers derive from controller base, so I'll add that to the class. I'll use the Quick Fix menu to add a using statement for the Microsoft ASP.NET Core.MVC namespace, and this also contains the route attribute. The URL for the route attribute looks the same as the one for the generated values controller. However, the second part, in the square brackets, is a variable that matches any valid controller name. In this case, the controller name is conference, so requests to API/conference will be routed to the conference controller class. Finally, I'll add the API controller attribute, which I'll discuss later. Inside of the controller, I'll use an instance of the data context class to communicate with the database via Entity Framework Core. We won't create this instance, rather it will be generated by .NET Core for us through the magic of the dependency injection. It's not really magic, but it is a big help. The data context instance will be provided via a constructor for the conference controller class. We saw the CTOR snippet to stub out a constructor earlier, so I'll use that again. And I'll change the name to conference controller. The constructor will expect an instance of the data context class, and I'll use the Quick Fix menu to add a using for server.models, and I'll name this CTX. Now I need a private field to store this instance for use inside of the class, and the Quick Fix menu can also do this for me. With the cursor over CTX, I'll press Ctrl+ and select Initialize Field from Parameter. This will create a private read-only instance of the data context in the controller and initialize it with the one passed to the constructor. So where does the data context passed to the constructor come from? That's generated for us by .NET Core through the dependency injection container. We'll see dependency injection in more detail later on. For now, know that when we added the DB context class to the application in the startup class, it registered the DB context with the dependency injection container. Then, when .NET Core sees that the conference controller class constructor needs an instance of the data context class, it will create one automatically. Again, we'll see this in more detail later on, but for now, just trust that it's working. With the context, I can now begin to write some action methods. And to open, I'll write one to get all of the conferences in the database. The action method will be public, and it will return a type of iActionResult. The name will be getAllConferences, and it will take no parameters. I'll add the HTTP GET attribute so that ASP.NET Core will invoke this action method if the request uses the GET method. Inside of the method, I'll create a new variable to store the conferences retrieved from the database. So I'll use the context, get all the conferences from the conferences DB set, and finally, I'll transform them to a list. ToList lives in the system.link namespace, which I can bring in with the Quick Fix menu. To return the conferences, I'll first call the OK method on the controller class, and then I'll pass it the conferences from the database, and then I will return the result of OK. This will transform conferences to JSON, and also return a status code of 200, which means the request was OK, or successful. This method is pretty useless right now, because it will always return an empty list, as there is no data in the database. So I'll create another action method that will add new conferences. This action method, as all action methods, will be public and will also return an iActionResult. I'll call it createConference, and it will take a conference as a parameter. Inside of the method, I'll add the conference to the conferences DB set, and then I'll save the changes. Now what to return here? There is actually no technical restriction on what status code to return. However, convention suggests that we should return a 201 status, meaning a new resource was created. And the controller provides a created method to do this. Now, in the body of a 201 status, it is also expected that an endpoint be provided with the location of the newly created resource. I'm not going to worry about that here. It's something we will implement later on. But to keep the demo moving along, I'll pass an empty string and null as parameters for created. This will return a 201 status, but no content in the body. Finally, I'll add the HTTP post attribute, so with this action method will be invoked for a post request. And I've got to remember to return created. So why am I using get to retrieve conferences and post to create them? Again, there is no technical restriction to enforce this. It's convention that is followed and accepted. To make a long story short, recall the 4 basic operations of a database, the CRUD acronym. These are create, read, update, and delete. Our API will follow the same pattern by mapping HTTP methods. So create will be post, read or retrieve will be get, update will be put, and delete will be delete. This is part of the REST convention, which also suggests what status code should be returned, such as 200 for a successful get and 201 for a successful post. We'll learn more about REST through the course, but for now, we can test our API in Postman. I'll go to the terminal in Visual Studio Code and I will run .NET watch run. Then I'll flip over to Postman. First, I'll make a request to get all of the conferences. So I'll go to the URL http localhost 5000/API, and this time, because I want the conference controller, conference. This will be a GET request, and now I can send it. The response is a JSON representation of an empty list, and this makes sense as there is no data in the database. So I'll change the method to post so I can create a new conference. The conference itself will be a JSON object that will be passed via the body of the request. It'll be raw text, and I'll specify a content type of application JSON. Now I can write the JSON. ASP.NET Core will look at the JSON object and try to match it to the type passed into the createConference method, which is a conference model object. So I'll need a pair of curly braces, and then I'll need a title. JSON requires that all strings be in double quotes. So I'll put title, and then I'll provide a value of conference1. Notice that the keys are not case sensitive. After that, I'll supply a date. JSON has no date type, thus I'll provide a string in year, month, and day. Finally, for the ticket cost, I'll use 250. And since JSON does recognize numeric values, I don't need to use quotes. I'll click Send, and while the body of the response is empty, the status is 201 created as we expected. So let's see if this really worked. One of the cool things about Postman is it saves all of your activity. So I don't have to create a new request to get all the conferences. Instead, I'll just click on this history item, and it even opens it up in a new tab. Now if I send this, the newly created conference is returned in a list. Now obviously there's a lot going on behind the scenes, so let's take a closer look. In Visual Studio Code, in the createConference action method, I'll place a breakpoint on line 28 before the method starts. Then I'll go to the debug panel. I'll select .NET Core Attach from the drop-down, and I'll click the Run button. I'll search for Conference Barrel Server in the list of running processes and select the one invoked with .NET EXE. Then I'll go back to Postman. I'll select the post request and change the value to conference 2. Then I'll send it. Visual Studio Code will stop execution and show the state of the project. In the local variables, notice that there is a conference object. And if I expand it, we can see that the properties of the object are the same as what was passed in the JSON of the request body. ASP.NET Core will attempt to match the keys in the JSON to the properties of the type of the action method. It will see a title, a ticket cost, and date. But what about the conference ID? Since that is auto-incremented, it is generated by the database. ASP.NET and EF Core are smart enough to know that the client shouldn't need to supply a value for the ID, and the default of 0 is used. The actual ID is generated when the context saves the changes. So let's see this. If I click the Step Over button in Visual Studio Code, I'll move to the next line. Now the conference has been added to the DB set, but the changes have not been saved. The value of the identifier has been changed, but it's not the final value. So I'll click Step Over once more, and the changes will be saved, and now the ID is 2. And if I click Continue, the 201 status is returned with the response. And Postman shows the same. If I send the GET method again, the 2 conferences are returned in the response. Before I hook this up to a client, there is one more thing I want to show you, and that is an easy way to inspect the SQLite database. As you might expect, it's a Visual Studio Code extension. So in Visual Studio Code, I'll go to my Extensions panel. I'll search for SQLite. And at the time of the recording, there's only a single result by AlexCVZZ. This is the one I want, so I'll install it, and then I'll restart Visual Studio Code. After code reloads, I'll press Ctrl-Shift-P to bring up the command palette. I'll search for SQLite, and I'll select Open Database in Explorer. It will find the Conference Barrel DB file and show it in the SQL Explorer panel. By expanding the tree, I can see that there is a Conferences table, which matches the Conferences DB set in the Data Context class, and the table has columns for each of the properties in the Conference Model class. I can also run queries on the database from inside of code. Again, I'll bring up the command palette and search for SQLite. This time, I'll select New Query. Then I can enter a SQL query in the New tab. I'll right-click in the editor and select Run Query. A split pane will open, showing the results of the query. Let's try another one. Again, I'll right-click, select Run Query, and the results will be updated. With that, we are ready to implement and hook up a client to the API. For that, I'll be using Angular. In the next video, I'll install the Angular tooling and scaffold a new project, and then use it to make requests to the API. After that, we'll have the first stopping point for the demo. Thanks for watching.